Hello everybody, welcome to Boolean Maths. This lesson today is going to be about trigonometry. It's pretty much an introduction to using right triangle trigonometry to find the missing sides of right triangles when you're given just an angle and a side. So, all right, let's get to it. All right, so let's review just the idea of trig in general. So with trigonometry, you have three primary trig functions. You have sine, you have cosine, and you have tangent. And what they do is they represent the ratio of sides associated with a particular angle. So take this triangle, for example. It's kind of a classic Pythagorean triple. It's a 5, 12, 13, so all the numbers are nice. And if I wanted to evaluate the three trig functions using one of the angles here, I would either pick A or B. You wouldn't use the right angle, at least not in this class, and actually majority of the time you don't. It's called right triangle trig for a reason. So I'm putting a ring around angle A there because we're talking about the sine of A. So relative to A, you have a side that's opposite. So let's just bring this up here. And so we have a side that's opposite. And then you have the adjacent, and then the classic hypotenuse is always the hypotenuse that's across from the right angle. All right, so where were we? Back over here. So let's look at this triangle and say, okay, we need to know what the sine of that triangle is. So sine represents the opposite over the hypotenuse. So we have hypotenuse here, we have opposite here. So now that I've color coded them, it's even easier. I'm going to say that the sine of angle A is equal to opposite over hypotenuse, in this case red over yellow. It's going to be 5 over 13. In this particular instance, we know all of the sides, so it seems sort of silly. We're establishing the relationship. Actually, if I asked you to find the measure of angle A, this would be a perfect way to do it because A is the variable here. Majority of the time when you're using this trig function, you would literally know what angle A is. It's like 15 degrees or something like that, and you're going to see that later. But this is still establishing the relationship. So relative to A, the sine of A represents the opposite to hypotenuse ratio. No matter how big or small this triangle is, as far as scale, if I doubled all the sides, it's still going to have the same relationship. All right, moving on. Let's do cosine. So cosine is going to be, let's keep our highlighting going. Hypotenuse, whoops. Hypotenuse is yellow, and then adjacent, let's make that green. So cosine is going to be adjacent over hypotenuse, or in this case, green over yellow. So cosine of A equals 12 over 13. Lovely. And one more. Good old tangent. In a previous video, I messed this tangent up. I reversed it, so let's be really careful this time. Tangent represents opposite over adjacent. So relative to A, 5 is the opposite, 12 is the adjacent. So you would say tangent of angle A is equal to 5 divided by 12, or 5 over 12, 5/12. And so that's pretty much the basics of your trig relationships there. Actually, this is still not solving problems. This is just to make sure you know how to use your calculator. You're going to need a calculator for this. If you're old like me, you maybe used a table of values. We had calculators, but with the teachers, they still made us use the table in the back of the book, where you would like look up sine of 30 and then write down the decimal, and then punch the decimal into a calculator. Just funny. Yeah, good times. All right, so I intentionally chose sine of 30 for this first one here because the sine of 30 is a great calculator check to make sure you're in the correct mode. So I'm going to just jump over to a scientific calculator. Desmos makes a nice one. And so I'm going to just choose the sine of 30. And you can see where the answer is. It's over on the right. Notice how there's two modes. There's degree right above the 7 and 8 here. There's degree and radian. You don't want to be in radian for this particular exercise. Actually, you don't want to be in radian at all in this class. You're going to be in degree. So that's why sine of 30 is a great check, because it's a terminating decimal. It's 1/2. Super easy, right? So if you want to know that your calculator is in the correct mode, quickly just do the sine of 30. If you see 0.5, you know you're good to go. Okay, so for this one, that's a terminating decimal. So you don't really need to round this one to 4 decimal places. You would just go 0.5, or even literally write out 1/2. But the rest, like if you look at tangent of 67, tan 67, go, and that's a 2.3559. 2.3559. 2.3559. Now I'm taking that to 4 decimal places only because if I needed to use this number again, and I'd typically be multiplying or dividing by it, when you multiply or divide by a rounded number, you significantly lose a lot of accuracy. If if you're finding an area or a side length or something like that. So it's recommended that if you're using that number again for some other computation, 4 decimal places is ideal. Like a lot of you are like, oh, what do I do with pi? It's 3.14. You should do 3.1415 if you're using the decimal. But just like with pi, tangent or sine or cosine, you really don't need to write the decimals down anymore. The calculators can handle multiple commands, and I'm going to show you that we're going to leave everything in terms of sine, cosine, and tangent for our computation. So really it's not too much of a worry, but I do recommend if you are writing the decimal, 4 decimal places, please. All right, and lastly, cosine of 53. So cosine 53, and that should be 0.6018. 0.6 or 0.6018. Is that what that says? Yes. Okay. Wonderful. All right. So hopefully you know how to use your calculator. Again, you might have a TI-84, or just maybe a regular calculator, scientific calculator. I do enjoy a free Desmo scientific calculator, so I would check that out. All right, let's go. Now we're going to solve problems. So in this particular example, they say find all of the missing parts. Okay, that includes angles as well. I'm going to focus right now, though. I'm going to just stick with the given information, and I'm going to just put some variables in. I'll call this side little a. I'm going to call this one little c. So I need to find little a and little c. Because we have our training wheels on, relative to a, this side is the opposite. This is the adjacent, and then across from the right angle is the hypotenuse. Notice the orientation of this triangle. The right angle is kind of up in the air there. So it's really important that you label these sides. Okay, so I want to find side A. So if I want to find side A there, that opposite side, that's an unknown. So now I need to make sure that I combine that with another side that is known. So I don't know the opposite, right? But I do. So, whoops. Here, just highlight over here. I don't know the opposite. I'm trying to find that, right? And I do know the adjacent. So I need a trig function with opposite and adjacent. So if we look over at SOHCAHTOA again, our little mnemonic for remembering, we have SO for sine, opposite, hypotenuse, cosine is ca, adjacent and hypotenuse, and then tangent is opposite and adjacent. I'm looking for opposite and adjacent, a relationship that brings them together, and that's going to be tangent. So that means that the tangent of our angle, 36, so we can say tan of 36 is equal to A over 7. Okay, so remember, tangent of 36 is a number. You could plug that in your calculator, write it down as 4 decimal places, but I'm going to leave it as a constant because I can easily solve this. What I tell my students to do a lot, I'll say just take that trig function, put it over 1. It makes them feel a little bit more comfortable with the cross multiplication or with the solving. Even though most of us learn that if you have a divided by 7, you would multiply both sides by 7 to solve. You're more than welcome to do that. But when you're first learning this, it's still technically also a proportion. It's just using similar triangles. So it kind of feels nice to set up that proportion there. So you cross multiply and you get, in this case, A equals, and I'm going to just emphasize the 7 as a number out front, so I'll color it blue. 7 times the tangent of 36. That's great. We've actually technically solved for A. So if you wanted to leave your answer like this, your teacher really can't tell you that you're wrong unless they explicitly said for full credit you need to round your answer to tenths. So I'm going to round my answer to tenths because I'm not going to use it again. So I'm going to take 7 times the tangent of 36 and plug it into my calculator. So 7 times tangent 36. And you can see that just one simple computation, writing tangent of 36 is easy to say and remember. There's no weird rounding with decimal, so you're good there. So my answer is going to be 5.1. I'm not using this number again, so 5.1 is fine. If you wanted to use this number now and use the Pythagorean theorem, now that you have two sides, you can, but then I would recommend rounding this to say at least 2, but I'd probably go 4 decimal places if you want to have a very accurate answer. So I'm not going to use the Pythagorean theorem because frankly I think that's really more work. Once you get the hang of the trig stuff, it's very nice. Okay. I did not mean to color that. Let's just get that sort of out of the way. All right, next up. So now I would like to just use my little ring here, and we need to know the hypotenuse this time. So that's side C, but we'll just say we need hype. And again, we were given adjacent. You don't want to use the side you just found because if you mess that up, you're going to corrupt your answer. So you may as well get at least one of them right? So I need to know the hype, don't know the adjacent. So which trig function involves hype and adjacent? So it looks like it's going to be cosine. Okay, so you'd write the relationship down. You know that the cosine of 36 degrees, you also don't need to keep writing that degree symbol out. We know we're in degree mode, so it's kind of a default. I'm writing that for you. Is equal to adjacent 7 divided by the hypotenuse. I'm going to color code this hypotenuse. I'm going to just make it blue. So let's focus on this equation. So this one's a little different. Sometimes students get the hang of doing this and they think every single time you're just going to multiply the constant times the trig function. Not the case here. So in this particular instance, I'll cross multiply. So I have 7 times 1 is 7. And then I have C times cosine of 36. So we have C, and then I'm going to put a little multiplication symbol there, times the cosine of 36. And that equals 7. So I need to get C by itself. C is the variable. Cosine 36, not a variable. That's a number. So I'm going to divide now both sides by the cosine of 36. Cosine 36. Okay, so those divide out. And so C is going to equal 7 divided by C equals 7 divided by the cosine of 36. Lovely. Let's plug that into our calculator. 7 over cos 36. 7 divided by cosine 36 is 8.652 blah, blah, blah. But like I said, 8.7 will suffice because this is our final answer. 8.7. This is about 8.7. So I can label that on the diagram. 8.7. Actually, over here too, I should have used about 5.1, right? It's not exactly 5.1. If I wrote equals, I could have said A is equal to, explicitly equal to 7 times tangent of 36. So because that's an exact answer. One thing that we forgot to do is they said solve for all the missing parts, right? So so we found out that A is about equal to 5.1. It's a really pretty sad A there. Let me try that again. Little c is about equal to 8.7, and the measure of angle B is going to equal, And I think you may know this already, but the sum of the interior angles is always 180. But if it's a right triangle, you know that these two angles add to 90 because the other one's already 90, right? So the acute angles of a right triangle are always complementary. So we can just go 90 minus 36. So this is going to be 90 minus 36. So 90 take away 30, 60, and then it's going to be 54 degrees. Okay. So this next example, this is where I would like to encourage you to pause the video and try to do it on your own. So yeah, I mean, you've seen just two basic solving problems. Majority of the time that trig would be used, though, would be probably in a real life setting. So let's take a look at a word problem. Usually with word problems, if they're nice, they'll provide a diagram for you, but oftentimes they're not. They want you to actually parse through the words and draw a picture on your own. So let's do this. So if you would like, again, to pause the video and try to do this on your own, I would highly encourage that because it would feel very nice to just do that and get it done and look at my answer, right? So we have a 60-foot ramp. So the ramp itself is 60 feet long. Rises from the first floor to the second floor of a parking garage. Okay, so I'm seeing something like, here's the ramp, and this is the thing that you're going up, right? Like that. So that's 60 long. So it's literally, it's not 60 this way, it's 60 up the ramp, okay? And it makes a 15-degree angle with the ground. When they say that, another way to say that is angle of elevation, and I'll just put that here. It has a 15-degree angle of elevation. So angle, whoops, that's not a highlighter. Angle of elevation. That means that the ramp is going up. Okay, so and the angle of elevation is always measured off of the horizontal. So I'm gonna, just for fun, draw a horizontal line. And then we're gonna I don't have tools to make a perfect 15-degree angle here, but I'm just gonna draw that line, and we're gonna say that that's a 15-degree angle. Okay, and then we're gonna have the second floor of the garage right at the top of that line. So let's put in another side to this triangle. I don't know why I'm using different colors, but I guess just because I can. And all right, so we have that, and we know that the ramp itself is 60 feet. So this is 60 feet, and I want to figure out, it says how high above the first floor is the second floor, right? So the second floor, and just for giggles, we can do this. I'm just going to pretend that we got to the second floor here. So this right here is the height between the first floor and the second floor, right? And your car is going to drive up that. Okay, so relative to the 15-degree angle, we have the opposite. We need to know the opposite, and we're given the height. So when you look at SOHCAHTOA, we know that that's the first one. Sine is opposite and hypotenuse, so we're in business. We can get started. So we know that the sine of 15 is equal to h. Let's make it a green h, over 60. And in this case, again, you could cross multiply or just multiply both sides by 60. 60, 60, and 60. All right, so h equals 60 times sine 15 degrees. Go to our trusty calculator. Times the sine of, did I say 60 degrees? I meant to say 15 degrees, sorry. Yeah, we have 15.5. So the answer to this question is, how high above the first floor is the second floor? About 15.5 feet. Okay, so that concludes our lesson on trig today. a future lesson will entail actually finding missing angles, and that would truly round out the whole using right triangle trigonometry to solve right triangles, meaning you can find any part when you're given just two pieces of information, a side and an angle. Okay, so good luck.